Ever look up at the night sky, filled with sparkling stars and distant galaxies, and wonder, how does it all end? We know how it all began with a Big Bang, but what's the grand finale for our universe? Well, physicists have a few ideas, and one of the most likely, and maybe a little bit spooky, is that a silent, invisible force is pushing everything away, leading to a future so vast and empty, it's hard to even imagine. This is the story of the Big Freeze, the ultimate fate of our universe. So for most of the 20th century, we had a pretty good idea of how things worked. The Big Bang happened, and the universe has been expanding ever since. Now, here's the key part. Scientists previously thought that the universe's expansion would likely be slowed down by gravity over time. Because gravity is a thing, right? It pulls everything together. Imagine you're driving a car and you take your foot off the gas pedal. The car will keep going, but friction and air resistance will make it slow down, right? In this story, the Big Bang is the foot on the gas, and the gravity of every star and galaxy is the friction. But in 1998, everything changed when two different teams of astronomers observed something strange in distant supernova. So the plan was simple. Look deep into space with powerful telescopes and find these special supernova. See how dim they look.
Just like a street light, the farther away it is, the dimmer it appears.
So, by measuring the dimness, you can figure out its distance. The team aimed their telescopes, spotted the supernova, did all the math. But when they looked at the results, something was off. The really, really distant supernova, the ones that exploded billions of years ago, were dimmer than they were supposed to be. At first, they thought they'd made a mistake. Maybe space dust was blocking the light. Maybe their telescopes were wrong. They checked everything, again and again. But the numbers were real. The supernova were definitely dimmer. And that could only mean one thing. They weren't dimmer because something was blocking the light. They were dimmer because they were way farther away than all the calculations predicted. These strange results led scientists to a wild conclusion. The universe isn't just expanding. It's expanding faster and faster over time. This surprising idea is now called cosmic acceleration. But that opened up a big question. Why? What's making the universe zoom outward like this? What invisible force is pushing everything apart faster and faster?
A mysterious something we call dark energy.
We don't really know what it is, but we can see what it does. It acts like a kind of anti-gravity. Think of it as a property of empty space itself. As space expands, more empty space is created, and this new space has its own dark energy, creating a bigger push. It's a runaway effect. The more space there is, the faster it expands, which creates more space, which makes it expand even faster. And this is where the Big Freeze begins. The expansion of space becomes so fast that it's actually moving that galaxy away from us faster than the speed of light. Imagine you're running on a racetrack, but the track itself keeps stretching faster than you can run. No matter how fast you go, the finish line keeps moving away. That's kinda like how light from faraway stars might never reach us.
Wait, I thought nothing could go faster than light.
That's true for objects moving through space. But here, space itself is stretching. There's no speed limit for the expansion of the universe. The night sky would become almost completely black. We'd be in our own little island universe with no way of knowing anything else was ever out there. We are alone. But at least we still have the stars. Billions of them, lighting up our galactic home. But for how long? Think of our galaxy as a giant cosmic bonfire. For billions of years, it's been burning bright. The fuel for this fire is the vast clouds of gas and dust that drift between the stars. When these clouds collapse under their own gravity, new stars are born, and, 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 the fire keeps going. But by now, in the era of the lonely galaxy, most of this fuel has been used up. New stars become rarer and rarer until eventually, the last bit of gas is ignited and star formation stops completely.
One by one, the shining stars of the galaxy will flicker and die, becoming cold, dead objects like black dwarfs and neutron stars.
After an unimaginable amount of time, the last star has died. The lights are out. Our galaxy is now a silent, frozen graveyard. It's filled with the cold corpses of stars. With all the stars gone,
The black holes are now the rulers of the universe.
eventually, some of these dead stars will be knocked onto a collision course with a black hole. As it gets closer, the immense gravity of the black hole tears it apart. The black holes slowly, methodically, clean up the galaxy, growing ever so slightly larger with each meal. But what about everything else? What about the trillions of black dwarfs and dead planets that don't fall into a black hole? They face an even stranger fate. Every single object not captured by a black hole will simply dissolve. Planets, asteroids, and the trillions of stellar corpses, all of it will decay into a thin, cold soup of radiation and stray particles. The only things left with any real muscle will be the black holes.
Thanks to the brilliant Stephen Hawking, we know that black holes aren't truly eternal.
They evaporate through a process called Hawking radiation. It's an incredibly slow process, like a mountain-sized ice cube melting one atom at a time. So now, even the black holes had vanished from the universe. Now, space is huge, dark, and almost completely empty. All that's left is a cold, thin mix of tiny particles, like lonely photons and neutrinos, just the leftovers of a universe that used to be full of stars, galaxies, and light. This final state is also called the heat death of the universe. This doesn't just mean it's cold. It means the energy has spread out so evenly that everything is the same temperature, just a tiny fraction of a degree above absolute zero. Think about it. Heat only does useful things when it can move from a hot place to a cold place. It's what powers our engines, our weather, and even life itself. When everything is the same temperature, nothing can happen. Time itself loses its meaning because there are no events to mark its passage. No change, no movement, no life, no thought, just a perfect, final, and eternal equilibrium. But don't lose any sleep over it. We're talking about timescales so enormous, they make the current age of the universe look like the blink of an eye. So for now, we can just look up at that beautiful, busy night sky and appreciate that we live in the exciting, energetic youth of the universe.
Lucky us! We get the fireworks phase of the universe!
Before everything fades into cold and emptiness, we still have some time. So enjoy the show while it lasts. Because the big freeze is the universe's way of saying, that's it. No extra lives, no restart button, just a frozen game over.